guys do? Turn off your microphones. Great. So today we have our third practical session. Please open the task, and we will start and end with the problem 2. It's a big task for pure exchange economy because we don't have time for short questions. They are easy, so you can do it by yourself. But problem 2 is the standard problem that you can find in your homework or midterm or exam or something like that. So we'll do it right now. So today we'll speak about pure exchange economy. It's the economy without production. Here in the task we have 2x2 endowment economy. That means that we have 2 consumers and 2 goods. So individuals A and B, and they have identical preferences over goods 1 and 2. The utility of individual I is xi1 multiplied by xi2 for I, A, and B. So for both individuals A and B, we have such preferences. You see that it is Cobb-Douglas preference. So what else? Let EI denote I's endowment. So individual A has initially 5 units of good 1 and 7 units of good 2. Individual B has initially 3 units of good 1 and 5 units of good 2. And our first task is to use Edward box to depict the initial allocation. So we should draw the Edward box. Let's do it. What means Edward box? It's the set of all feasible allocations to our 2 individuals. We know that how many units of good 1 is in the economy right now. We should sum up the endowments. 5 plus 3, 8. And it will be on horizontal axis, so it will be width of our Edward box. E B1 plus E B1 is equal to 5 plus 3. It is 8. It is width of Edward box. We should sum up endowments of good 2 to find out height of Edward box. E A2 plus E B2 is equal to 7 plus 5. It's 12. Height. So now we can draw. We start with individual A. Put the dot. This will be the start, our axis. And the maximum amount of good 1 you can consume is 8. So this will be x A1, and the maximum is 8. Maximum amount of good 2 that individual A can consume is 12. And when our individual A consumes both 8 units of good 1 and 12 units of good 2 at the same time, individual B does not consume anything. So this will be the starting point for individual B. Horizontal axis x B1, vertical axis X, B, 2. And we can put the dot of initial endowment. Individual A has 5 units of good 1 and 7 units of good 2. 5 units of good 1 is over here. And 7 units of good 2 is over here. And at the same time, individual B has 3 units of good 1 and 5 units of good 2. The same. 3 units of good 1 and 5 units of good 2. So this dot is the point of initial endowment. Guys, please, is it clear? So, what else? In this task, here is a question. Will the individuals be willing to trade? And explain your answer. What that means? It means that in some situation, our individuals have having initially such endowment. They want to trade with each other and to become both better off. So, can they make the Pareto improvement of their situation both? Let's see. What means Pareto efficient allocation? Is the situation when no one wants to when no one can be better off without making somebody worse off. And with interior solution, what that means? For example, if this endowment point somewhere here, for example, and from this allocation, each individual gets some level of utility. Yes, so we have here indifference curve for individual A, and we know that it's the shape of this indifference curve, it's a hyperbola, yes? And the growth of utility to this way. And at the same time, individual B also has gained some utility level from this point. And his utility grows to that direction. So if we are in such situation, we see that both can be better off. Yes, here. This is the set of Pareto improvement points. What they can do? They can both get higher level of utility. And this will be the tangent point. This is Pareto optimum point. If we don't have a tangent point or a tangent line, same for both individuals, this point is not Pareto efficient. So we can have gains from trade. We can move to the left and up, and everybody will be better off. So there will be gains from trade. And how to prove analytically that this point is not Pareto efficient? Pareto efficient point is when they have the same tangent line. So their marginal rates of substitutions are equal in this point. Here, margin rate of substitution for A is equal to margin rate of substitution for B. In the endowment point for A, in the endowment point for B. So this will be Pareto efficient situation. In this situation, they have different slopes of their tangent lines. Let's see. So in such situation with such endowment point and such utilities, they have different tangent lines. You see different slopes of their indifference curves. So their marginal rates of substitution in this point are not equal. And if they are not equal, so it's not efficient point. Here, margin rate of substitution good A is not equal to margin rate of substitution good B. They're not equal, and moreover, margin rate of substitution for good A is less than margin rate of substitution for good B. You see the slope for individual A is lower than the slope for indifference curve for individual B. And what that means? That means you see that we want to move to the left and up. So individual A wants to sell his endowment of the first good and to buy more second good. So in such situation, A will be the seller of good 1 and buyer of good 2. We can have opposite situation when we have endowments over here, and their Pareto improvements will be here, opposite. But at this point is also not efficient. So there will be also gains from trade. So let's check. Let's check. First of all, we need to prove that we don't have corner solutions. So we can use this condition for efficiency. Because if we have corner solutions, for example, this is access for individual A, and we can have, for example, such point, and this point will be, Pareto efficient in what situation? Let's see. For example, this will be the utility for good A, and this will be the utility for good B. Or no, like this. And you see that we want to have Pareto improvement, but all these points are not feasible for us. So we cannot improve our situation because these points not feasible. So this point, this corner solution, will be Pareto efficient point. So because we cannot be better off without making somebody worse off. That's all. So this will be Pareto efficient point, because all Pareto improvements are not feasible. So now we should prove that there are no corner solutions. So we can use our marginal rates of substitution to check. Let's start. Let's write down. Given the preference structure, there are no corner solutions. How we can prove it? Let's fix the utility for individual on some level, on some constant level less than infinity, and rewrite, for example, x of individual I of the second good is equal to this level of utility divided by xi1. You see that this is hyperbola, and if the consumption of individual I of good 1 is almost 0, we want to consume, in such situation, we want to consume the second good infinite number. Yes? But such point is not feasible for us for our equation. Same for good 2. For our both consumers. That's why optimal points will be interior points, not corner but interior. So we proved it. Next. So now we can use for Pareto efficiency, we can use this condition. We know that raise we know that if the initial allocation constitutes equilibrium, constitutes sufficient point, if the initial allocation constitutes optimum, it must be margin rate of substitution for individual A in endowment point should be equal to margin rate of substitution for individual B in the endowment point. Let's find margin rates of substitution, put this point and check. Margin rate of substitution for individual I, because they have the same preferences, it's what? Partial derivative for the first good divided by partial derivative for the second good, by the second good. And this is what? Partial derivative from the first good, it's xi2 divided by xi1. And let's put the endowment point and check. So this will be second good in the endowment point 7 divided by 5 for A. And you see that it is not equal to 5 divided by 3, which is margin rate of substitution for individual B in the endowment point. And moreover, 7 divided by 5 is less than 5 divided by 3. So our first conclusion that our endowment point is not efficient, so we will have gains from trade. Is not efficient. So I will have gains from trade. And one more conclusion is that our margin rate of substitution for individual A is less than for B. What that means? For A, this for B. Right improvements will be to the left and up. So individual A will wants to sell the first good, then part of endowment of the first good, and wants to buy second good. So A will be seller for good 1, buyer for good 2, and vice versa for individual B. Individual B will buy the good 1 and sell the good 2, such that they will make birth improvement. So that's all for point 1. Please ask if you have questions. Then, what's next? Then we continue to speak about Pareto efficiency, and now we will find all Pareto efficient allocations that are in this edgework box for such economy. All Pareto efficient allocations lies on the contract curve. It was in the lecture. Let's start. We should find the formula for our contract curve. All Pareto efficient allocations. Who decides how to allocate resources, how to allocate goods efficiently without prices? Without prices, it's the social planner who does it. Social planner, it's like big boss who's sitting up and tell that you will consume this amount, you will consume this amount without prices, only allocation, distribution of goods, like in USSR. So, in such situation, our social planner solves the maximization problem. he maximizes the sum of utilities subject to feasibility constraints. Let's write down, it is called centralized solution. So, social planner maximizes by choosing XA1, XA2, XB1, XB2, greater or equal than 0, the sum of utilities of both individuals, lambda multiplied by utility of individual A plus 1 minus lambda utility of individual B depending on his consumption. So this is the sum of the utilities where lambda is how much consumer A contributes to the aggregate utility. Let's write down this belongs from 0 to 1. This is how much individual A contributes to aggregate utility. That means how social planner, what constraint, how social planner cares about individual A, in what proportion to individual B. Okay, how important individual A is for society, for social planning. Subject to not budget constraint, but feasibility constraints. The consumption of, for example, good 1 by individual A and individual B should be less or equal than endowment of this good in the economy. And for good 2, same, feasibility constraint. XA2 plus XB2 less or equal than the endowment of this good. So this is the maximization program of social planning. Check that there are, notice that there are no prices in this maximization program, only optimal distribution. And we know what will be the solution, how to solve such problem. First of all, we need to prove that our feasibility constraints will be binding, holds with equality. This is the first step. And then we can write down Lagrange with two constraints, yes? And we know what first order condition will be. Marginal rates of substitution should be equal, and they should be equal to the, this ratio of Lagrange multipliers, and that's all. So our first step. Let's say that that preferences of each individual, you see that they are monotonic, yes? Preferences of each individual, XA1 multiplied by XA2. They are monotonic preferences, but in this module, we will say we will use more, we'll use other explanation that preferences of each individual are locally non-satiated. What means monotonicity? Monotonicity means more better. So for each allocation, allocations that are strictly better lies somewhere to the right and up. There are better allocations. This is monotonicity. You remember from the first course. This monotonicity. What means locally local non-satiation? That means that here lies not only to the right and up, somewhere located the point that is strictly better. somewhere, not only to the right and up, but there can be, there should be the points, for example, here, that is strictly better. Here, the growth of utility, or here, yes, strictly better. We don't know. So this is more local non-citation is more is wider, yes, wide. And also that means that if references are locally non-citated in our edgework box, that means that there are no citation points. You remember such situations when we have ideal, for example, weight and height of the model, and our indifference curves looked like this, and this will this point will give us maximal utility. So if references are locally non-citated, there are no such citation points, and that's all. Okay. So, and we see. So we can say that if references are monotonic, they are locally non-citated, and that's all. But let's use this explanation. So references of each individual, of both individuals, are locally non-citated. That means that feasibility constraints holds with equality. Then, second, we proved that there are no corner solutions for Pareto efficient allocations, and for interior solutions, the solution to this maximization program is that marginal rates of substitution are equal to each other. Marginal rates of substitution of first good to the second good for individual A should be equal to marginal rate of substitution of individual B, and should be equal to the ratio of these Lagrange multipliers. These are Lagrange multipliers and this ratio shows us the ratio of shadow prices in the economy. It's economical explanation of such a mathematical term. Shadow prices. Ratio. What that means? This ratio will show us what prices we will be if there will be the market. We know that for Pareto optimal allocations, for centralized solution, we don't have prices, we don't have markets. We have only distribution. And this ratio will show us shadow prices, like black market, yes? This will tell us what prices will be if there will be the market, if markets will appear in the economy. So we know marginal rates of substitution. Let's solve. Marginal rate of substitution for individual A, x2A divided by x1A is equal to x2B divided by x1B. But as we want to write down the equation for some curve, we should write down it in some x's. Here are both x's for A and B. Yes, but we need an equation in one axis. So how we can rewrite? We know that our feasibility constraints holds with equality. So the consumption of good 2 by individual B is how much of this good is in the economy minus how much individual A consumes. Yes, second good, 12 maximal. So it will be 12 minus the consumption of second good by individual A, divided by 8 minus x1A. Here we used feasibility constraints. So now let's rewrite. This will be 8x to A minus x to A x1A. This is 12 x1A minus x to A x1A. And rewrite. X to A is equal to 12 divided by 8 x1A, or 3 divided by 2 x1A. We see that this is the equation for the graph is line. Yes, and that's all. Same, we should write down for axis for individual B, the equation for the same contract curve. For individual B, how we can rewrite? Also use the feasibility constraint. 12 minus x to B is equal to x to B divided 8 minus x to x1b. Here x1b. And from here, when we express in B terms, would be the same similar. X to B is equal to 3 divided by 2 x1b. And now we are ready to write down the equation for the definition of the contract curve of the set of all Pareto efficient allocations for such economy. So the contract curve is the bundle for consumption of individual A, XA1, XA2, the consumption point for individual B, XP1, XP2, such that they are, these points are feasible, such that the consumption of individual I of good 1 belongs from 0 to 8. The consumption of individual I of good 2 belongs from 0 to 12, so they are feasible. And all Pareto efficient allocations lies on this curve, on this line. And we should write down the expression in for both individuals on the same curve. So this will be xi1 is equal to 3 divided by 2 xi2. So, how to draw the contract curve on our axis? What it will be? It will be a diagonal line. Yes, you can check if individual A consumes 8 and 12. This point. Let's check. 8 is equal to 3 divided by 2 multiplied by 12. That's true. So this will be a diagonal one. What else? Let's draw. And you should draw carefully. Why? Because we remember that from endowment point, we want to move to the left and up. So Pareto efficient allocation should lie here. to the left and up to this endowment point. So our contract curve will be diagonal line, which is higher than endowment point. This is line. This is line. Is equal to 3 divided by 2 x I 2. Why it is necessary to write down the equation for individual A and individual B of this contract curve? Because we have in this task we have a symmetric situation, but in other tasks you can find that contract curve is something like this. And you see that the equation in A axis is not the same as equation in B axis. For A, it will be the arrow from 0, 0, yes. And for B, it will be also with positive slope line, but with a positive constant. Different equations for the same line. Okay, so it is necessary to write down both equations in both axes. So let's continue. Next. In point 3, we should find competitive equilibrium. What that means? This is a decentralized solution, decentralized. When social planner does not act. When both individuals, they trade with each other, there are prices, they trade with each other, and it is standard competitive equilibrium. What that means? Competitive equilibrium consists of the allocation, equilibrium allocation, and prices, and price vector. Allocation. And price vector. Such that this allocation maximizes utilities of our individual subject to budget constraint. Yes, and this allocation is feasible for us. X maximizes individual utilities given price vector. And this allocation is feasible. This is exactly the same then if we say that market's clear. Market's complete, market's clear, the same. In each market we have equilibrium price and equilibrium quantity bought and sold. What's next? And this is the decentralized solution when social planner do not intervene. Decentralized solution. So let's start. What we should do. Each individual maximizes his utility given budget, subject to budget constraint. So we should maximize utilities. For example, for individual A, let's write down his utility. x1a multiplied by x1b. We should maximize it by choosing xa1, xa, here xa2, xa2, non-negative, subject to budget constraint. What means budget constraint for our individual? His expenses on buying these goods in money terms, so this price of first good multiplied by the quantity of the first good that is bought by individual plus price of the second good multiplied by the quantity that is bought by individual A. These are expenses should be not bigger than his income. Income in money terms. Now we have his income in natural terms. He has now endowment point 5 units of good A of good 1 and 7 units of good 2. How to make it in money terms? Let's multiply by prices and that's all. So price of good 1 multiplied by EA1 plus price of good 2 EA2. And this we can call the endowment of individual A in money terms, capital E. So this is the maximization program. What we should do? First of all, we should say that budget constraint is binding, holds with equality. Why? Because reference of our individual are not locally not stated, for example. Then, what else? We should say that there are no corner solutions for such problem, for such maximization problem, but we proved it in the point 1. So let's say budget constraint binding. Why? Because reference is locally non-stated. Second, no corner solutions. Why? See point 1. We proved it in point 1. And then for interior solution, what is the optimal condition? Marginal rate of substitution should be equal to the price ratio. You remember? Yes, this is budget constraint. This is difference curve. This is optimal condition. So marginal rate of substitution individual A should be equal to the price ratio. So let's write it. X to A divided by X1A should be equal to P1 divided by P2. From here, we write express X to A is equal to P1 divided by P2 multiplied by X1A. We have one equation but 2 unknowns. Where we should put this optimal condition? Into budget constraint. Let's put this into budget constraint, this optimal condition, and we rewrite P1 multiplied by XA1 plus P2. Instead of XA2, we write this optimal condition multiplied by P1 divided by P2 multiplied by X1A. And this should be equal to this endowment in money terms. From here, easy. We will find the demand of our individual A for good 1. And actually, you can maybe you remember that this is the function, this is Cobb-Douglas function, and we know the formula for demand. You don't remember? Alpha divided by alpha plus beta multiplied by income divided by the price. But if you don't remember, you will use this. Yes. So the demand of individual A good 2, it's income divided by 2p2. Same for individual B because he is symmetric. These are demands for goods, given prices, given price vector. Then what we can find? We can find this optimal price vector that supports our competitive equilibrium. How we can do it? We will use feasibility constraint. We know that both demands, for example, for the second good of our individuals should be equal to the endowment of this good. Yes? So let's use it. Use feasibility to find price vector or price ratio that supports competitive equilibrium. That supports competitive equilibrium. Okay, x a1 plus x b1 should be equal to 8. Yes. Let's do it. X a1. Let's write by putting this endowment point. So endowment of individual A. It is price of good 1 multiplied by the endowment of the first good for individual A. It's 5 multiplied by 5 plus price for good 2 multiplied by the endowment 7 divided by 2p1 plus demand of individual B for good 1. Endowment in money terms for individual B. This will be price of the first good multiplied by how much initially our individual B has. This good 3 plus P2 multiplied by second good endowment 5 divided by 2p1. And this is equal to 8. From here, we can find price ratio. Let's do it. So 5 divided by 2 plus 2 divided by p1 multiplied by 7 divided by 2 plus 3 divided by 2 plus p2 divided by p1 multiplied by 5 divided by 2 is equal to 8. From here, 7 plus 5 is 12. 6 p2 divided by p1 is equal to 5 divided by 2 plus 3 divided by 2 is 4. 8 minus 4 is equal to 1. Price of good 2 divided by price of good 1 in competitive equilibrium is equal to 2 divided by 3, or we can revert 3 divided by 2. How now we will find allocation, competitive equilibrium allocation. We'll put this price ratio into demands and we'll find the point. So XA1 is how much? So it is 5p1 plus 7p2 divided by 2p1 it is 5 divided by 2 plus 7 divided by 2 multiplied by P2 divided by P1, and it is 2 divided by 3. This will be 15 plus 14, 29 divided by 6. And how I can find the consumption of individual B of good 1 very fast. We know that both they consume 8 of good 1. So his consumption will be 8 minus how much individual A consumes. So here use feasibility. This will be 19 divided by 6. Then same for second good. X A2 is equal to 5P1 plus 7P2 divided by 2P2. This is 5 divided by 2 multiplied by P1 divided by P2. 3 divided by 2 plus 7 divided by 2. And this is also 29 divided by 4. So the consumption of individual B of second good is the endowment 12 minus 29 divided by 4, and this is 19 divided by 4. So competitive equilibrium consists of two things. Price ratio, P1 divided by P2 is equal to 3 divided by 2, and optimal allocation. Consumption of individual A, 29 divided by 6, and of second good, 29 divided by 4. Consumption point of individual B is 19 divided by 6, 19 divided by 4. You can compare this competitive equilibrium allocation with the initial endowment. Compare with 5, for example. 29 divided by 6 is less than 5, because 5 is 30 divided by 6. So our individual A definitely sold some amount of good 1. Yes? So he is definitely the seller of good 1, and he bought a little amount of good 2. Why? Because 29 divided by 4 is bigger than 7. 7 is 28 divided by 4. So he sold a good 1 and bought the good 2. So A definitely the seller of good 1 and buyer of good 2. And we know how much he sold. Yes, he sold 1 divided by 6 of good 1 and bought 1 divided by 4 of good 2. This difference. Okay. And one little subpoint for this point 3 of this task is to find excess demands. Excess demands for goods. What that means? Excess demands. By definition, excess demand of individual J for good I is the difference between how much he wants to consume and how much he has initially. Is the difference between the demand of individual J for good I and his endowment of this good. And for example, let's find, we don't have too much time, so let's find excess demand of individual A for good 1. This is the demand of individual A for good 1 minus his endowment of this good. And this is how much? XA1, it was 5P1 plus 7P2 divided by 2P1 minus how much? Minus 5. He had initially Yes, and this will be 7 divided by 2, P2 divided by P1 minus 5 divided by 2. So this is the excess demand of individual A for good 1. And you can find all these, all 4 excess demands at home. But you can check that in competitive equilibrium, let's see, P2 divided by P1 is how much? 2 divided by 3. Put this. 7 divided by 2, 2 divided by 3, minus 5 divided by 2. This will be 14 minus 15. Yes, it's minus 1 divided by 6. So he definitely sold 1 divided by 6 of the first good. You see, this is the excess demand. It is negative because individual A is the seller of good 1. Yes, you see, and this is how much he sold with such price ratio in equilibrium. Да, ну смотрите, нас спрашивают excess demand именно в общем виде. То есть, когда спрашивают demand, да, ну как в общем виде, да, мы должны записать с отношением цен. Вот. Нас спрашивают не то, сколько он в итоге продал. Да, если был вопрос, сколько он продал, можно было бы легко так сказать, ну вот, минус 1, что вот из того, сколько он в итоге потребляет, вычесть, сколько у него было, ну вот столько он продал. Вот, она спрашивает именно excess demand как формула, как функция. Вот, да, поэтому будем писать вот так в общем виде. Вот, окей. Continue. Next step. Also, we should put this competitive equilibrium on the graph, and also the question is this allocation in competitive equilibrium, is this allocation is Pareto efficient? If this allocation is Pareto efficient? How we found this allocation? We solved 2 problems. We solved 2 maximization problems. We maximized the utility of individual A, the utility of individual B, subject to boundary constraints and what was first order conditions. Marginal rate of substitution of individual A should be equal to price ratio, yes? Marginal rate of substitution of individual B should be equal to the same price ratio. So in optimum, marginal rates of substitution of individual A and B should be equal because they are equal to the same price ratio. So this allocation will be Pareto efficient. And this is simple how to explain if this competitive equilibrium allocation is Pareto efficient, yes, but we can use the theory that was in your lecture and that you should use. We can use first fundamental welfare theory to answer this question. First fundamental welfare theorem tells us that if 2 conditions hold, then competitive equilibrium is Pareto efficient. What 2 conditions? Easy. Preferences of each individual are locally not situated. Preferences are locally not situated, and markets are complete. Markets clear or markets complete. What that means? That means that in each market, markets complete. In each market, there is positive price and positive quantity bought and sold. So two markets exists. Both markets exist. With optimal price greater than 0 and optimal quantity sold. So, okay, and if these 2 conditions holds, and they hold in our task, then competitive equilibrium is Pareto efficient. That's all. So our competitive equilibrium allocation is Pareto efficient. Okay?
Еще можно все равно через заморозки сказать.
But you will check this. You should check this. Put this point into marginal rates of substitution. They will be equal, so you will say that yes, this point is definitely Pareto efficient. Okay. But our lecture likes this theory. Okay, let's move on. No, not one. Let's put this competitive equilibrium allocation on the graph. Where it will be. We know where it will be. It will be somewhere here. Yes? To the left and up. Then endowment point, for example, here. This is the budget constraint. This is the budget constraint with the slope -3 divided by 2. Remember, this is budget constraint. This is the competitive equilibrium point. And it moves from endowment point to this competitive equilibrium point. So we move from endowment point by trading. By trading, we move from this endowment point with such prices to this competitive equilibrium point, and it is definitely Pareto efficient point. It lies on the contract curve. How we do this? How we do this? You see, for our individual A, this is budget constraint. Yes, budget constraint. And he maximizes his utility. This is the last tangent point. At the same time, for our individual B, this budget constraint also his budget constraint. You see? And he also maximizes and find the highest indifference curve for him, the same point. So this is how we find competitive equilibrium. Okay, then now what to do? Okay, let's do the fourth.
Еще вопросик. Получается, в таких задачах по факту всегда же будут выполняться, да, эти два условия?
Да. Ну, у нас потом там будут экстерналии. Вот в случае экстерналии, когда, типа, вы помните, ну, мы же там слышали, там, когда, там, не знаю, какое-нибудь предприятие реку загрязняет и делает плохо рыбакам. Да, и вот эти вот выбросы в реку, это тоже товар, вот, ну, типа товар, но на него нет рынка, поэтому возникает проблема, возникает экстерналия. Вот, да, и поэтому тогда не будет выполняться, да, там будет конкурентное равновесие, но оно не будет Парето эффективным, да, вот, из-за того, что рынка не существует на эти выбросы. Вот, но вот некоторые правительства, да, они делают рынки для, помните, знаете, вот есть такие аукционы на выбросы в атмосферу. Вот, они создают для таких вот там плохих вещей, для экстерналей, они создают рынок, да, прям торгуют вот разрешением на эти выбросы и таким образом достигают эффективности. Вот, но это уже государственное вмешательство, да? Вот, так. Четвертое. In the fourth point, we need to take any Pareto efficient allocation on the contract curve. We should take any Pareto efficient allocation and decentralize it as a competitive equilibrium with transfers. Take any Pareto efficient allocation and decentralized it as competitive equilibrium with transfers. So what we should do? First of all, we should say, can we do it? Can we do like this? Can we decentralize in such situation? We will say yes, because we have second fundamental welfare theorem. That tells us if our preferences are locally non-satiated and convex or concave? Convex. And convex. And mark is complete. Then we can take Pareto efficient allocation and decentralize it. Make it competitive equilibrium with transfers. Our preferences are local, non-satiated, and convex. That's true, and mark is complete. Convex, that means that the shape of indifference curves looks like this standard shape of indifference curves. Okay. Let's take any Pareto efficient point. For example, let's take xa1 equal to 1. xa1, for example, equal to 1, then xb1 will be equal to how much? 8 minus 1. 7. xa2 will be equal to how to find? We can put xa1 into a contract curve equation, So put into contract curve, and this will be 3 divided by 2, multiplied by 1. So xb2 will be equal to 12 minus 3 divided by 2. It's 21 divided by 2. So this is our point. 1, 3 divided by 2, and 7, 21 divided by 2. For such point, it lies here. This is our point. For such point, we should find optimal price vector prices. So the slope of budget constraints and transfers. What means transfers? One individual gives money to the other individual. That's all. Such that we will move this budget constraint to make this point a competitive equilibrium point. So what transfer will be? Individual A should give money to individual B. Yes, you see? Let's check it. So our first move is to find the price vector that supports our competitive equilibrium. Find price vector that supports this point as competitive equilibrium. How we can find this price vector? We know that marginal rates of substitution are equal and are equal to the price ratio in equilibrium. So marginal rate of substitution for individual A should be equal, for example, for price vector. We know in this point, Pareto efficient point. Yes? Marginal rate, it's xa2 divided by xa1. And this is 3 divided by 2 divided by 1. So this is optimal price vector that will support our equilibrium, and it was easier logically because it's the same slope. Yes. We found. Then let's find transfer. For transfers, we need to have not only price ratio, optimal price ratio, but we should construct price vector. Let's construct price vector. Let's say, suppose the price of the second good we normalize to 1. We can do like this. So in equilibrium, price of good 1 will be equal to how much? 3 divided by 2. Then let's define. Let's define transfer. Let's say the transfer T. Let's say T is the transfer from individual A to individual B. So, and then if we will find that this transfer is positive, so individual A gives money to individual B. If we will find that this transfer is negative, so individual B gives money to individual A. But we define like this right now. Okay, so for example, the demand of individual A for good one will be how much? With transfer right now. It will be his new income. You remember his income was EA, E capital A, but now he gives money to individual B, so minus T. His new income divided by 2P1. Yeah. So this will be 5P1 plus 7P2 minus transfer divided by 2P1. And let's solve. XA1 in our point that we should decentralize is 1. So 1 is equal to 5 divided by 2 plus 7 divided by 2 multiplied by P2 divided by P1, 2 divided by 3, minus T divided by 2, P1. P1 is equal to 3 divided by 2. I reverse. So from here we will find transfer. Let's do it. 6 everywhere. So 6 equals to 15 plus 14 minus 2t. 2t is equal to 29 minus 6, 23. So transfer is equal to 23 divided by 2. So we'll check. Right. Yes. So we found that our transfer is actually positive. So individual A gives money to individual B. A gives money. Money is part of income. To B. And it was we saw it on the graph. Yes. So before the transfer, budget constraint was like this, and now A has less income because he gave transfer to B. So his budget constraint moves to 0, 0. Yes. And on this graph, we can show everything. So this will be new competitive equilibrium. This was our point. The slope is the same, minus 3 divided by 2. And where we can show this transfer, you see, for individual A, for example, budget constraint was like this. And here was EA divided by P1. Yes? Income divided by the price. And now it is income minus transfer divided by price. So this difference is transfer divided by the price. This difference is transfer divided by P1. So what else? So we decentralized, found what we found. We found so this Pareto efficient allocation can be decentralized with price vector 3 divided by 2 and 1 and transfer from A to B equals to 23 divided by 2. This is the answer for the first problem. So, okay, that's all for today. The first problem there are two short questions. They are easy after we solved all these big problems. So you can do it at home easily. So please, guys, ask questions. I will start raising. If you don't have questions, see you next Tuesday. Так, вопросы? Ну, короче,
Решение нам отправить, потому что не видно было в некоторых моментах.
что, еще раз, что отправить, записи или видео?
Можно записи ваши, без разницы.
Ну, это попозже. Вот я вам первый, второй семинар прислала, вы получили? Там я всем
Да.